Okay. Today I would like to talk a little bit about two main system of construction of road pavements, and giving you a main overview of some issue, especially related to the durability of these two kind of material that are used for the transportation roadways. I will go through a brief introduction, and I'm talking about concrete roads and comparing them to some of the asphalt roads we investigated, and then focus a little bit on the durability issue that arises in these two systems, and then going through the conclusions. As you all know, there were times where most of the main building materials and also road materials consisted of stone, and is here an example of Naples. Naples in Pompeii, where very big, large stone were used to build up the street. Today, the streets are actually still made of stone, a smaller stone, actually aggregate stone, that are mixed with several binders, some mineral binder and more organic binder for asphalt road. Today, we also actually use, again, a little bigger stone for some street, especially in the cities, in small villages center, and they use actually cube stone that are linked together, connected together with mortar, and most of the stone are locally used stone around the region of the Alps. They mainly use granitoids and gneiss and quartzitic rocks, and in some other places they use other type of rocks. This type of streets are actually very durable, but they are very time consuming, because sometimes every cube needs to be put by hand, and so the application, it takes a lot, and in the meantime the distances are actually exploded, and the other material and technique are used to cover the roadways. If you have a look on the literature research, you can see that generally it's stated that the concrete road exhibit a superior durability that goes around to 15 years and actually a little longer also, as compared to asphalt road that are thought to last for at least 15-20 years before a first restoration, at least of the first layer, surface layer, is done. This differences actually depends on the material property, for instance, but also on the condition of the service condition of the roadways, in this case the load condition, the frequency of the load, the material that it used, and also the environmental issues and the atmospheric exposition to which the roads are actually exposed. It's used also to say that on the initial cost and on a long-term basis, and considering also the life cycle of a material, the concrete road actually appear to be a little more convenient than asphalt road. Although in addition, the bitumen are construction material that are made of organic binders, and these organic binders actually could be also used as a fuel or to produce energy. In general, we can say that the rigid pavements, such as concrete, some cementitious material in general, but concrete, appear to reduce the fuel consumption because of the less resistance of the tire when they rolls, as compared to the asphalt pavement. This is also due because of the rigidity also, and this makes a little difference in these two type of material. The load distribution in this concern on a rigid pavement, as for instance concrete, is more widespread on the surface, and locally the stresses are less intense as compared to flexible asphalt road pavements. So in addition, the thermal impact, so the material is also, actually the asphalt material is black, and the thermal impact and measure heat and light reflection may be also accounted for this material. So stone aggregate exposition actually may better reduce the noise sometimes of these rolling tires as compared to this new asphalt, noise absorbance asphalt, which porosity sometimes on a long-term basis is filled with material, and these pores are actually closed, and they reduce this effect of noise mitigation on a long term. Volatile organic carbon are also a concern in asphalt. For instance, in case of fire, in particular in tunnel, whereas sometimes in tunnel they also use a special mixture, but when the fire explode, these volatile carbons that they just flow into the air, but also during the natural and conventional atmosphere with time. And in this concern, in this fire resistance concern, the concrete exhibit actually a better behavior because it exhales less toxic gases and doesn't promote the combustion with exothermic reaction that actually reduces the mechanical properties of asphalt pavements. On the other hand, this asphalt pavement, they don't need junction to be put along the surface, and also the technological improvement made them in these days and the last decades appropriate to be used for highways, in particular where the car are exhibit a higher speed, and in most streets after worldwide. We compared some study, we look at some study that was done on similar conditions, exposed to similar condition, a 3.5 kilometer long Portland cement concrete pavement and asphalt concrete pavement on the Canada Highway, which actually exhibited on this short period a well performance in both cases after 5 winters. I mean, the concrete actually indicated a little better profile ride and riding comfort index, as well as friction values, while the ACP section exhibited a slightly lower noise level reduction. Another advantage actually that can be seen in asphalt is that it can be placed quite quickly than concrete, and they also provide a better safety of the vehicles against snow sometimes and skating compared to cementitious materials. As already probably stated, Portland cement concrete pavement or concrete with supplementary cementitious material nowadays, because of the sustainability, they have a more initial costs regardless of the concept index value, but Portland concrete cement pavements, they exhibit significantly lower maintenance and rehabilitation costs than hot mix asphalt along the roadways. Again, also the life cycles indicate lower environmental pollutions at the production stage and also on the health impact at a construction stage for concrete pavement as compared to bituminous materials. We had a look on some cases and we have seen some substitution of concrete slabs on a street which was about 400 meters above sea level, and they put like concrete with a strength class C30, so 30 megapascal, with exposition class, so high exposition class resistance to carbonation, chloride diffusion, and freeze resistance, so in generally high durability against these several corrosion types induced by CO2 or chlorides and freeze those. We had a maximal aggregate diameter of 32 millimeters and the chloride content, and the workability index was good. And we measured compressive strengths on the curbs and the pavement, and you can see actually the mechanical property, they are well about 50 megapascal, which are actually very high resistance in this type of concrete. Also, the resistance to freeze and thaws, which respect the exposition class XF4, exhibit in general for the pavement slabs and the curbs sampled on site. They exhibit quite a good resistance on the freeze thaw attack, I will say. Concerning the chloride migration coefficient, some of the value, they were above the 12.12 minus 10 minus 12 square meter per second. We can see some value that ranges between 13 and 15, some of them reach also 18. And the exposition class XD3, which is actually the maximum exposition class of material, cementitious material that resists the penetration of chloride, is not always respected. Although this is sometimes not a problem if the steel rebars or the steel nets are enough embedded in depth on the concrete, and the concrete cover over the steel is high enough, is thick enough, let's say at least 5 centimeter, and the concrete is actually a high quality concrete. If we have a look also on the water permeability coefficient, you can see that the measurement that we carried out, that the value are pretty much below 10 to 12 gram per square meter per hours. And this is an indication that concrete exhibit a high waterproofing quality. We also investigated some old concrete slab roads, which are actually 50 years old. As you can see, these slabs are jointed. The junction are necessary because of the thermal expansion of the slab. And some of the slab actually, during the years, they exhibit with respect to each other. And sometimes the junction are actually adversely affected by the atmosphere, and some water, they crack. Sometimes they need to be repaired with this bituminous material. Sometimes you can see it on the right picture. And sometimes the water also infiltrate downward into the unbinded material and causes a leaching. And this leaching of the fine material cause a vertical movements of the underneath pavement background basement, and so that the concrete slabs sometimes they move vertically with respect to each other, and then they cause like a movement when the car, or a noise when the car goes through this junction. And this is actually also a problem that needs to be taken into account. From the concrete road, you also can see sometimes water leaching, some stone aggregate on the left picture up. Stone aggregate are actually exposed, and the roughness with the times also increases because of the better tire adhesion that is maintained. And in the left picture below, sometimes you can see tire mark residues, which is actually an indication of the roughness that is partially maintained in this concern. On the upper picture on the right, you can see that sometimes there is a surface treatment or finishing of the concrete slabs. This is just a ramp, a slope that goes down to a parking garage, for instance. And you can see that there is a riffling and striation of the surface to maintain the necessary roughness. This is also sometimes this surface preparation method are also used for street, actually, and not only for street like heavily trafficked street. If you look at the picture right on the below, you can see the texture of the street border, which is actually, it exposed the aggregate and they are more visible. And this is actually due to the water leaching and enrichments that is increased due to the artificial slope of the street that causes the water to flow on the side of the street to the water drainage. And during this flowing action, sometimes this fine graded cementitious material that holds together the stone aggregate is leached away, and the aggregate are exposed on the side of the slab. There are also some problems. So in the concrete roads, so aging problem due to load, shrinkage of the material, sometimes fatigue, and this you can see some of the issue that may appear. So we have sometimes longitudinal cracks along some concrete slabs. The curve also causes high surface shear stresses, and these shear stresses also put in tension this slab and causes the formation of cracks, or sometimes you can see in the left picture, in the middle picture, you can see longitudinal cracks on slabs that goes from joint to joint. And along the junction on the right picture, sometimes you can see a tongue-like fracture that is sometimes due to the freezing action. This was a street covered with concrete slabs and was like more than 2,000 meters above sea level. Sometimes during restoration work, asphalt is put on concrete slabs, on some old concrete slab, and with this overlay. And in this concern, it is important to avoid what is called reflection cracking of the asphalt of the cover top. So sometimes they put like, they introduce some asphalt joint or sufficient asphalt overlay with a minimum thickness 200 millimeters in order to avoid this reflection cracking that comes up from the junction of the concrete slab. The thickness also or the minimum thickness that you want to apply also depend on cracking content and the conservation state of the underlying concrete slabs. We had some also these systems of asphalt roads that they are sometimes composed of 3 or 4 layers of different asphalt types, depending on the load and frequency of the traffic that goes through the travels through this pavement. And here are some possible asphalt types, or there is a big nomenclature on type of material that depends on the binder type, the hardness, softness, polymer addition, aggregate size. And you can see that basically there is a foundation layer at the very low level, a base layer, a binding layer, and a top layer that goes up all through the system. And generally, the conventional roadways are composed of 3 layers, and highways are sometimes composed of 4 layers of asphalt material. Here is a highway, pretty much trafficated highway. Yeah, you can see some more cavity and macro voids on the surface region. Is a 15 years old highway structure. While underneath in the layer underneath, you can see a more compaction because of the load of the material, the compaction of the compression of the material. Although along the interface of some layer, we can find also some porosities and pores. As I said, in conventional street, they usually apply only 3 layers, with a top layer with mastic asphalt, basically, and then a binder layer of foundation, or a binder and a base layer. And in generally, the aggregate, they turn from a coarser size to a finer size from the bottom to the top of the asphalt system, because this bigger coarse aggregate, they give a sort of support of the surface material to the traffic, to the load of the traffic. If we have a look on the durability issue of asphalts, we can see that the main issue is actually the oxidation of the bituminous binder in the warm paving phase or during the time. And sometimes the volatile component of the binder, of the organic binder, actually the maltane, passes into the air, they evaporate, and the more rigid asphaltanes remain as a component left. And this process actually makes the bitumen with time more rigid, and with time then increases the susceptibility to cracks. And the bituminous binder systems actually exhibit the viscoelastic property. We are also more dependent on the temperature as compared to to concrete. And sometimes the crack, they form along the hydrophobic bitumen layer, while in concrete, the main crack formation is actually located in the weakness part of the material, which is actually the cement paste or the cement aggregate interface. Just to give you an idea of the binder content in asphalt, they ranges organic binder content. They range between 2 and 6% by weight. In concrete, they reaches up to 15% by weight. In the cementitious material, the cement paste form a gel that surrounds the stone aggregate and compact them together with time. And the durability is actually only affected by some of the reaction that can occur along the interface between the cement and the stone aggregate. For instance, alkali silicate reaction, sulfite attack, or freeze toast attack that may create cracks and then scaling of the concrete surfaces. While CO2 and chloride sometimes doesn't play a big role if the concrete cover over the steel rebars is high enough. It's also important to notice that both concrete and asphalt need to be considered as systems with the different pavement layers on the asphalt and with the concrete material or slab and the foundation, so that some of the working issues such as placing or the service condition, temperature, weather, compaction, segregation, type of joints, aggregate and gradation and volume all plays or may play a significant role in the durability of this type of pavement. Here are some example of the asphalt roads defect when we can see the thermal action crack at 2,400 meters above sea levels on the top left picture. Down left, you can see some slope on both sides of the street, on the right and the left side. In the middle, you can see a crack going all the through to the longitudinal of the street, and perpendicular to this longitudinal crack, some transverse crack they may form, and you can see the picture on the right below. While on the right up, you can see the different fine binder presence and fine particle presence on the asphalt surface. One of the main issues was also this deformability of this asphalt material, so that when they put like this, the circles, these roundabouts in the streets, this shear deformation is actually, shear stresses are highly present, and they tend to form quite a lot of cracks, as you can see on the left pictures. And also the vehicle, they also leave some track left into the material because the material is deformed. And so sometimes they use to construct these roundabouts of these round circles with concrete slab that are actually jointed because of the high rigidity of the material. A similar thought is also made for the bus stops, because the stops in the part of the bus causes again shear stresses and tension on the road pavement, and these tend to form cracks, as you can see on the left, on both left pictures. And on the right picture, you can see that in this case, it was not used like a concrete material or a concrete slab with junction. This is also a bus stop, but it was used a material, an asphalt material with open voids on the surface, and then in the open voids, they added a mixture, a cementitious material mixture that filled up the open space and make the material more rigid, although there is also a possibility to use bituminous or bituminous material that are more rigid, but in this concern, they tried a mixture between cementitious material and asphalt material in order to diminish the effect of shear stresses. The unbinded ground material, as I said, the materials must be considered as a construction system, and also the unbinded ground material, so the compaction of the materials, play also a significant role to get durable asphalt pavement. And so ground subsidence, this is actually a clear case of a mountain street that goes up. You can see that there are many factors affecting this formation of cracking along the left side of the street. So freeze-thaw attacks, leaching, unbinded material on the left side of the street. On the slope, this is leached away, and the street tend to crack because of this support that is no longer presence of the unbinded material. There is also an emerging technique, which is actually called the roller compacted concrete, which is actually the concrete is compacted with a roller, and the material is like similar with a conventional concrete, although with a lower content of cement, a more dry mixture, and the material doesn't flow actually, and is compacted with a roller. And this technology needs actually to be implemented in order to construct, I would say, conventional roadways. At the moment, it's just used for secondary level roadways. There is also a topic to investigate the addition of alternative aggregates, a recycled aggregate or reclaimed asphalt pavement, rubber addition, plastic addition in asphalt pavement with respect to the compatibility of the mixture, packaging, surface treatment, and all these investigations are currently done in the concrete and the asphalt pavement technology. As you can see in this comparison, concrete actually it gives like an homogeneity and the quality of the recycled aggregate, but this needs to be taken under control because of sometimes the porosity is highly present. So we need to find new binder, not, but a good appropriate binder and superplasticizer in order to be able to use high percentage of recycled material, which can go up to 15%, 50%. And also for the asphalt, the rigidity of the old binder must be taken into account, and sometimes rejuvenator material are added to the old binder in order to use the recycled asphalt pavement. Although for the top road levels, it's in some country actually is still forbidden to use reclaim it because of the quality is concern. They that not achieve some of the rule imposed by the normative. So to conclude, I will say that concrete and asphalt exhibit similar basic material feature of a system which consists of binder and rock aggregates. The characteristic, nonetheless, the characteristic of the bituminous binder of the asphalt is completely different. So the thermal susceptibility, the viscosity and elastic behavior are also different. The asphalt are layered systems. The concrete are, I will say, double layered, so concrete and the unbinded layer underneath. So there is a need to adequate adjustment of the binder for cement and bitumen to make this material an aggregate applicable. The compaction make actually both systems applicable, although the absence of the frequent junction makes the asphalt widely used as compared to concrete. On the other hand, the durability of this bituminous pavement appears to be a little lower as compared to concrete pavement because of the high shear stress resistance that is not withstand by this asphalt material. Both materials are able to incorporate recycled material almost to 50% for the concrete. Within the asphalt, this needs to be a little bit to be more investigated, and some investigation are also going on in the mixed alternative of the two material and technological improvement to increase rigidity and durability of the pavement in order to get pavement without junction that can last a little longer. Thanks for your attention.
Thank you so much, Dr. Kristen, for sharing your insights on this topic. So the floor is open for discussion. Are there any questions?
I want to ask a question. Christian, I want to ask you, as far as I know, sometimes there were few works in literature where addition of nanomaterials or different other fillers to, like to polymer, also to concrete, can improve their strength, durability, and whatever. Did you familiar with such techniques, and do you know something if people try to use this in your field?
Yeah, also you must consider that in both material, actually, concrete and asphalt, there is many polymeric addition that are ongoing. Yes. From one side, from the asphalt material, for instance, is to try to reuse the recycled asphalt pavement, especially for the surface layer. So, and they're working a lot with these rejuvenator types, which are actually not very easy, but they're trying to implement research in this concern. And also for the durability issue, the oxidation and the rigidity. And for the concrete, there are also many addition, actually, more in direction, because the concrete is quite durable. So they do some addition mainly because of the sustainability of the material, and they do a lot of supplementary cementitious material like fly ash, silica fume. Nanoparticles are also used in concrete, sometimes graphene also in some cases, in order to maybe reduce or the porosity or the corrosion. And it's true, yes. I mean, the polymer science is actually quite active in this concern to improve this material, and also the fiber addition in rolled concrete pavement is one issue that is currently under investigation.
Yes, exactly. Fibers may be something that can strengthen it. Yeah, exactly. Maybe not only polymer, but some metal or metal compounds.
Yeah, exactly. They use sometimes plastic, they use sometimes basalt fibers, and sometimes metallic fibers. Yeah.
Thank you so much.
Thanks to you.
Oh, yeah, thank you so much, Dr. Kristen. So the floor is still open for the discussion. Are there any other questions?
Sir, hello.
Hi.
Sir, hello. Good evening, sir.
Good evening.
I wanted to know whether the aspect ratio is being checked there. I mean, the materials that are included, what are the aspect ratios that you are considering? Because aspect ratio plays a key factor when the stress, I mean, the shear stress that is acting, the breakage of the materials that is occurring. So the optimum aspect ratio should be considered, because a higher aspect ratio will always bring about a breakage when a load, I mean, extra amount of load will be applied. Yeah,
you mean aspect ratio of the stone aggregate, the granulometric distribution? Okay,
yes, sir.
Okay.
All the materials that is being included. As
sure.
a composite.
No, this is a good observation. Actually, one of the aspect ratio also influence in particular for asphalt roads, but also especially for concrete, also the workability, actually, because the longer the higher the aspect ratio, the more difficult sometimes is the workability of the material. But this is also an issue, a main issue in concrete, and then also an issue in the asphalt road, and also not only the aspect ratio, but also the packaging of the granulometric distribution of the stone aggregate. They're trying to optimize also, you know, the packaging and the volumetric content on the different grain size to optimize and sometimes to reduce the cement addition in concrete material because of the sustainability. If you add less cement and you get the similar results, you are more sustainable because the CO2, the cement production requires CO2, for instance. And also for the asphalt, because, okay, although in the asphalt, the bituminous binder is also, the dosage is also pretty much low as compared, for instance, for cementitious material and concrete.
Yes. Thank you.
Thanks to you.